In this question number 19, we have given consider a non-pipeline processor with a clock rate of 2.5 gigahertz. Okay, so we have one non-pipeline processor and the clock rate is given as clock frequency or clock rate is given as 2.5 gigahertz. Okay, and average cycles per instruction. Okay, so CPI, clocks per instruction or cycle per instruction, is given as 4. The same processor is upgraded to a pipeline processor if this processor is upgraded to a pipeline processor with 5 stages, but due to the internal pipeline delay, the clock speed is reduced to 2 gigahertz. Okay, so in the pipeline system, pipeline processor, now the clock rate is reducing to 2 gigahertz. Okay, and in the pipeline processor, ideally the CPI or clock per instruction will be 1. Okay, so CPI will 1. What is the CPI? CPI is actually clock per instructions. Okay, so to execute one instruction, it will take here 4 clock cycles, and to execute one instruction, it will take here one clock cycle in pipeline systems. Okay, so we have to find the speed up achieved in this pipeline processor. So basically the speed up is time consumed in the non-pipeline processor, divided by time consumed or time taken in pipeline processor. Okay, so time consumed in non-pipeline processor to execute an instruction, and here also time consumed in pipeline processor to execute an instruction. This will give the speed up. Okay, so let's suppose we have an instruction to execute. So in this non-pipeline processor, the clock rate is given as 2.5 gigahertz. It means the time consumed in one clock cycle will be time of this clock cycle will be 1 divided by 2.5 gigahertz, which is 0.4 nanosecond. Okay, so if we have to execute an instruction in this, and one instruction takes this 4 clocks, so totally for an instruction it will take 4 into n, and in one clock cycle the time consumed is 0.4 nanosecond, so 0.4 nanosecond, so totally 1.6 nanoseconds into n here. This is the time required to execute an instruction in the non-pipeline processor. And in the pipeline processor, one instruction has to execute in the one clock cycle, and we have to execute an instruction, so totally it will take again the time consumed in one clock cycle is 1 divided by 2 gigahertz. It means 0.5 nanosecond. Okay, now 0.5 nanosecond, and the time consumed to execute an instruction will be an instruction, and each instruction takes only one clock cycle because it is the pipeline processor, and in the pipeline processor ideally the CPI should be 1. Okay, so n into 1 clock cycle, and the time consumed in 1 clock cycle is 0.5 nanoseconds, so 0.5 nanosecond, so totally it will take 0.5 nanosecond into n. This is the time consumed in this pipeline processor to execute an instruction. So our speed up equals to time consumed in non-pipeline processor to execute an instruction, which is 1.6 into n in nanoseconds, divided by this in the pipeline processor 0.5 into n nanosecond, so it will give 3.2 speed up. So its speed up achieved is 3.2. so right answer will be option A.